Okay, what are we going to do? I'm going to give you some answers to the million questions I keep on getting, which are always the same ones, which is totally fine because I failed to answer them in class. So answer to most frequently asked questions so far before the midterm is, when's the midterm? Anybody want to answer that? Tuesday, thank you. So it's Tuesday in class. Can you bring a calculator? Can you bring your cell phone? You can bring pencils and a straight edge, right? I'll give you everything else you need, and some colored pens that aren't red or green. Is there a review session? Yes, it's tomorrow, 2 to 3:30 p.m. in 2060 VLSP, which is a room that looks exactly like this one that's somewhere else in this building, all right? So show up. The way my review sessions work is you come with questions and I answer them, right? They could be old problem set questions, could be anything you want to know, or say, Max, income substitution effect really confuses me, can you try it again? What happens with income substitution effects if the good is perfect complements for somebody? Whatever you want to ask, 1.5 hours, I will answer your questions and I will draw live, all right? Will this be podcast? No, because we don't have the ability to set this up in different rooms and then actually end up in iTunes U. That'll be in 2020, okay? So that's the review session tomorrow, 2 to 3:30. Come ready with questions. The last most frequently asked question, or third most frequently asked question is, will you post answers to problem set 2? Yes, I will. I frankly just forgot. So I will post them this afternoon, typeset in all of their glory, so you will have those. Are there any more questions? Oh yeah, fourth most frequently answered question. Max, I'm signed up for a different review session. Is that a problem? The answer is no. You can go to any review session you want. This is week 5. You should have figured this out 5 weeks ago. And last but not least, what's going to be on the exam? Economics, all right? Economics up to the end of last lecture. Max, will you screw us by making half the points on the exam about that last graph we drew last lecture? No, right? I try to be fair. My questions are tricky sometimes, as you see from the old midterms, but I'm not out to get you. If you come in and you answer all my questions and it takes you 20 minutes to do so, I will give you a high five, another high five, and I will look at it, and if the answer's all right, I'll give you a hug, all right? That's how excited I will be that you understood what I'm talking about. So hopefully no trickery, slightly complicated questions here and there, but the exam is designed that if you came to class, you did the problem sets, and you did the sort of standard amount of effort, you should be able to get 60 points, very, very quickly. Then the question is, how do I get to the A+? That's going to take a little bit more work. All right? Any more questions? That's it? I don't see well. Okay, we're good. Let's go. So this is the beginning of the material for midterm 2. What we did last time is we looked at short run production. We of course know that the short run is the time period in which one of your inputs, at least one of your inputs, is fixed. Somebody came up to me afterwards and said, Max, in political economy, I've done more thinking about what capital means and labor and capital complementarities and who owns capital and what that means for labor and sort of productivity trends over the past centuries. So if capital is fixed, does that also make labor partially fixed, and how complicated does this get? The answer to this is we're going to keep it simple here. I'm going to assume that you can change labor freely as much as you want in the short run, and capital is fixed. Is it always the fact that labor is the variable input and capital is the fixed one? Not necessarily, right? In some strange situation, it's easier to add capital than it is to labor, and then the variable input is capital. But for the purposes of this class, labor will be the variable input, capital will be the fixed input. Could be the other way around, but we'll keep it simple. Then what we did is we drew this total production curve, which I'm going to draw again, and from it derived the average product and marginal product of labor. The marginal product of labor answers the question, how much does output go up by if I add one more unit of labor? So it depends on where you are on the total product or total output curve. Product and output to an economist are the same thing, all right? So if you're worried about what's the total product curve and the total output curve, I use those interchangeably, and most economists do. So average product of labor answers a different question. That means overall, or across all workers hired, what's the average output per worker? So it's not how much output does the last worker hire add, but across all workers, the very productive ones and the not so productive ones, what's the average output per worker? And that's a different curve. So we'll draw this again in a second, but we saw that average product is a little bit like an inverse U-shaped curve. Marginal product increases, then decreases, cuts average product at the top, and then goes negative somewhere. So that's where we ended up. We didn't really talk about long-run production very much last time, but we're going to do today. I copy and pasted this slide. Darn it. We didn't talk about this last time. This is today. All right. Any questions about short run? Many, but we don't have time for your questions. I'm joking. I always have time for your questions. Call me sometime. All right. This is the drawing lesson from last time. I'm just going to do it rather rapidly because you've seen it. If you want to see it on iTunes again, there's this wonderful replay feature. You can watch me draw this 50,000 times. But seeing things drawn live, it's like seeing Billy Joel sing live at AT&T Park versus seeing a YouTube video of Billy Joel seeing him live. It's just pretty awesome. Not that I'm the Billy Joel of economics by any stretch of the imagination. Okay, so the total product, or total output curve, is this. If you took a regular U, the right side of a regular U, and then on top of it stacked an inverse of a U, that's what the total product curve usually looks like. So on the y-axis you have output, on the x-axis you have labor, and you hold capital constant. Okay, so capital doesn't change here, it's fixed. Oui. You ever seen a Formula 1 tire change? YouTube, watch it. It's amazing. So what we've got here is we hold capital constant in the short run. We'll see what happens in the long run. And for a given level of capital, in our example was 8 units, we increase labor and we see what happens to total product. Then we learned that there are 3 points on this curve where interesting things happen. At the inflection point, where the right side of that U shape hits the inverse U, that's called an inflection point. Thank you for not drawing, Microsoft. Here we go. Right? At this point here, we know marginal product goes from being increasing to decreasing. So to the left here, MPL increasing, to the right here, MPL decrease. We also know that something happens at the top of the total product curve where that thing is flat. Come on, there we go. Beautiful. At that point, what happens here? Marginal product, the slope of the total product curve goes from being positive to being negative, right? So to the right here, MPL is negative. To the left here, MPL is positive. The last thing we need is the point where average product goes from being increasing to decreasing, and that happens where the line from the origin is tangent to the total product curve. Right, so right at this point here. So that's roughly 7 units of labor, a little bit less than 7 units of labor. So to the right here, average product of labor is decreasing. And to the left here, average product of labor is increasing. So if I wanted to draw this, what I would do is I would start with my average product of labor, which increases and then decreases to the right of 7 units of labor here. So I've drawn my average product of labor. And then what I'm going to do is I'm going to sketch out my marginal product of labor, which increases to the left of this black line right here, then goes to decreasing, cuts through the top of the average product curve, and then goes negative right here. I'm going to scrape out the units here, because the way I drew this, I just sketched this. The actual units of marginal and average product of labor you'd have to figure out in a spreadsheet and draw it exactly to scale, but doing that on the fly is next to impossible. Question. Tell me your name again. Right. Brian.
Should the APL curve and MPL curve start at the same point on 1?
So that's a really good question, right? So for our example, they do, right? Because we go from 0 to 5, and the first worker always has whatever the marginal product and the average product of labor are the same thing. So there's the sort of hand-wavy answer saying we're never going to produce there, so it doesn't really matter, right? And that's certainly true. But you're right? So what I should do is I should draw this thing to big dot start somewhere here. You're correct. I'm wrong. Well, not wrong, but that's how it's correctly drawn. But we will see, and after 20 years of doing this stuff, it's become so second nature to me that I'm 10 weeks ahead of you in the sense that I know we will never produce here. So what goes on down here really isn't that important. But you're absolutely right. When I teach this concept, I should do it precisely. All right. So what we're going to see is you're going to produce somewhere here. But why that is, we're going to learn in a lecture or two. All right. So you should be able to draw this, right? Not to scale, but you should be able to draw this nice average product and marginal product of labor curve so it looks something like this. And today we're going to move into marginal cost curves and average cost curves, and we will relate this depiction of production technology. This is how we're combining labor and capital into output, right? This is the transformation. This is at the core of what a firm does. It's transforming labor and capital into output. We're going to turn this into costs. And those costs are going to determine how much output the firm produces and what combination of inputs it uses to produce that output. Question?
I missed a statement.
Yeah.
When you're talking about the marginal product of labor,
Yeah.
Oh, I see. Never mind.
You got it?
Yeah, it's the 2 points.
It's the inflection point.
Yeah.
It's where the thing goes from, it's that the joint convexity to concavity point is where that happens. Okay, so let's get to another law. The law of diminishing marginal product. What this means, if you increase a single input, right, hold capital constant, and you increase labor, which is our variable input in the short run, the corresponding increases in output will become smaller eventually. So as you add more and more labor, at some point, not everywhere, but at some point, the marginal product of labor is going to start dropping. So if we look at the graph again here, if we look at our marginal product right here, right, marginal product increases, so marginal product is rising, but what the law of diminishing marginal product says, there will be some point where it's going to start dropping. Right, so the notion here is you have 1 or 2 or 3 espresso machines depending on what size Starbucks store you have, but at some point if you add more and more and more labor, right, you exhaust these benefits from the division of labor, and we'll talk about this sooner rather than later, but this notion of that people separate the taking the cash from the doing the pastries to doing the coffee, and there's 2 people doing pastries and 2 people doing coffees and 2 people at the cash register, but at some point once you start having 4 or 5 people doing pastries or serving pastries, people start getting in their way, and the additional marginal product from that one person here is going to become smaller and smaller. If you had 120 people behind the counter at Starbucks on Center Street, that 120th person would probably diminish the output because you have so much congestion behind the counter that overall output actually goes down. But what the law of diminishing marginal product says is not everywhere is marginal product of labor decreasing, but at some point, eventually, as you add more labor, the additional amount of output produced by the last worker hired will be smaller than that from the previous worker hired. That's what it says. What it does not say, right, so this is my standard question I ask on an exam every year to get 20% of the class who slept at the wrong point. We shouldn't confuse diminishing marginal product, which is the next worker produces less additional output than the previous worker. So if the previous worker produced an additional 10 units, the next worker hired produced only 8, we have diminishing marginal product, right? But still output goes up, right? That next worker still produces 8 additional units, we're producing more output than before. Some people think there's no difference between this statement and that statement. What about a law of diminishing product? A law of diminishing product would mean as you hire more workers, overall output will go down. Right? So diminishing marginal product talks about the first partial derivative of the total product curve, the slope of it, versus total product talks about the level or the absolute magnitude of the curve. So if we go back to our graph, we have diminishing marginal product happening here, right? Marginal product is falling, versus diminishing product, total output falling, only happens down here. Right? And it turns out we will never produce down here. So what we're going to see after I explain this with a lot of hand waving and song and dance, no more performance pieces unfortunately, is that we will produce always in the portion of the marginal product curve where the marginal product of labor is actually falling. We will never produce in the area of the marginal product curve where marginal product is negative or total product is falling. All right? But why that is I still have to explain to you. So don't confuse diminishing marginal product and diminishing product. Right? So people, and you know more about Malthus than I do, right? Because you've all read, the great thinkers of the last 400 centuries. Professor Karras, with his revamped slides, they're really beautiful, has taught you how to critically assess these thoughts. Khalid Kadir, everybody's favorite instructor in PE 101, has gotten you excited about 20th century thinkers. So you've thought about this way more. But my simplistic econ brain, I wish I had sort of Ananias and Khalid's more global view. I'm narrower than that. When I think about Malthus, right? What did Malthus say? No, that was his mistake, right? What did he say? Right, actually. You guys are already way ahead of me. Yeah, so that's exactly right. So the notion here is that there's eventually this diminishing marginal product here will lead to resource scarcity, and we will run into major problems feeding the world. What did he hold constant? That we're holding constant in these pictures as well. He held technology constant, right? So assuming, or roughly constant, we could have an argument about that. But he basically assumed that marginal product curve was constant, right? And you just sort of wander down the marginal product curve and eventually exhaust, the marginal product of the additional acre of land would become so small that, we couldn't feed the ever-growing population. But technology changed quite a bit. In fact, is anybody taking the food course right now? Mark Bittman, Michael Pollan, it's like the all-star rocks, the all-stars of the local and healthy foods movement are teaching a course on the Berkeley campus right now. So you can't just read Mark Bittman in the New York Times, you can actually see him on campus. I want to talk to the guy because I have some issues with what he's doing, but that's different. His cookbook is excellent. Food policy, we're going to have to have a talk at some point. But the notion Now I got sidetracked. Let me step back into my expertise and out of my rant mode. Are we growing corn in the same way today than we did 500 years ago? Is anybody here from the Midwest? I love the Midwest. All right, how are we growing corn today in the United States?
In giant farms that are 100 acres and usually use circular irrigation.
That's exactly correct, right? So there's some irrigated corn, some non-irrigated corn. But those of you who like Douglas Copeland's writing, there's a really awesome chapter or short story or book, I forget what it was, I read it, about how corn is harvested. Basically, you take a giant combine, right? And one person, sometimes two, basically go down the fields back and forth, and the productivity of these combines is huge. We throw fertilizers, pesticides onto GMO-engineered corn that is resistant to certain types of herbicides, so it takes out all the weeds, but not the corn. The amount of corn we squeeze out of each acre in the United States today compared to the amount of corn people squeezed out of farms 500 years ago is astonishing. I have the graph, but I can't get it to show on the screen. I'll start next lecture with that. But it's, almost an order of magnitude over time. So technology has changed significantly, so the number of people you can feed out of the then marginal unit of land is significantly higher now than the number of people you could feed out of the best land a couple hundred years ago. So technological change is huge. Is that debate settled? So one of the smartest people I know, David Lobel. Anybody here know who David Lobel is? All right, well, you do, of course, thanks. Sam, our grad student, knows who David Lobel is. I would be really worried if you didn't, right? But the point here, David Lobel, he's in his 30s. He's published about, 70 papers. He won a MacArthur, as he should have. A nice guy, excellent tennis player, good dad. He works on food. In the 21st century, right? What does it take to feed potentially 9 billion people? In fact, at Stanford, where he is, and we'll forgive him for that, he teaches a class on what's it going to take to feed 9 billion people. So if you look at the yield improvements that are going to be required in order to feed 9 or maybe 10, there was a really interesting paper in the last issue, or 2 issues ago of Science. If you look at population projections by 2050, 2100s, yields are not growing fast enough to actually get us to the point we need to get to in order to feed those 9 billion people, even with the large-scale, agricultural production systems we have arranged today. What else is changing? 97% of all scientists agree that something's changing. 100% of this guy agree that it's changing. All right. It's climate, right? What does climate mean? What is climate? Weather pattern. Well, right? Weather is short-term fluctuations. Is it rainy today? Is it warm today? Is it not so warm today? Climate is a long-run average of weather. It's usually a 30-year average of weather. That's the climate experience in California. Why do you live in California? Well, Berkeley is here. I got in. I'm going to school, right? But why do you live in California? It's 70 degrees outside yesterday. Anybody been to Chicago yesterday? I had a call with a friend. It was 10 degrees. Okay, it was cold. So we live here because the climate is pleasant, and we can walk around in board shorts year-round. Well, the other thing that climate change is going to do, we know it's going to shift temperature patterns around, so it might get warmer. San Francisco will look more like Fresno in the long run. But the more worrisome thing from this point of view here is going to shift around precipitation patterns. So you're seeing all of these extreme snowstorms on the East Coast right now. New York keeps on getting hammered with these extreme snowstorms, and a bunch of politicians who've never been inside a science classroom in their lives keep on saying, oh, you've got more snow. How about that global warming? Well, may I tell you how it works? If you have a pot of water and you make it warmer, what happens? There's more evaporation. If it hits a cold atmosphere, what happens to that evaporation? It turns into snow. Well, let that bucket be the Great Lakes, small body of water up there. If it gets warmer, there's more evaporation, or whatever it's called. Hits cold atmosphere, winds blow it down. You may actually, in the world of global warming, see more snowstorms in the winter, right? So I'm going to get off my little soapbox in a second and teach you what I'm saying here. But with these big thinkers and big thoughts, like we're always, in a term paper, you're supposed to come to one conclusion and, defend it well. And this is why I hate judging debates in high schools, because you're supposed to, always make this one point and then in the end everything ends in nuclear war, which is really, out of the debates I've judged, 9 of them ended in nuclear war somehow. But the point here is, for a lot of these bigger problems we have here, like the simple Malthus problem that you've beaten to death, the problem has become very, very complex because you have technological change playing in, you have different consumption patterns playing in. It's not just that people are, more people are going to eat more calories. What do people do that have higher incomes? Are they happy with eating low-quality rice? What's happening to demand? They want protein, right? People want protein. People want shrimp. You want your 99-cent grilled, lime-seared, blackened Thai, avocado, whatever, shrimp tacos at Rubio's, right? If you go to, China or you go to India, you see if you go to a lot of events, in the past, it would have been much more sort of vegetarian and vegetable-based options, but protein's becoming a big thing across society. So the amount of calories necessary to produce a pound of protein are just simply higher than the same calories produced in grain. So I'm not trying to make you all go vegetarian, even though, I am still overweight. I don't know how that works. Could be all the chocolate. But the point here is, from an energy balance point of view, it's not just how much grain does it take to feed more people. What's grain going to be used for, right? And what are the calorie demands of people going to be here? So you've got a switch in the mix from, grains or largely vegetable-based diet to a much higher concentration of protein in the diet. You've got water issues, which are going to be exacerbated by climate change and many issues. Because where does irrigation water come from in California? 80% of all water in California is used for agriculture.